Today, we'll discuss the last topic for resultant of forces, which is resultant of non-concurrent force system. As usual, let's have a bit of an introduction. So the effect of an unbalanced non-concurrent force system on a body is to give the body a motion consisting of a combined translation and rotation. So the translation effect is determined by the resultant R, and the rotational effect is determined by the moment of the resultant force. So previously, for concurrent force system, we only had resultant R. And then for resultant of parallel forces, we got our moment M. So therefore, resultant of non-concurrent force system is a combination of concepts for both concurrent and parallel forces. Okay? So we're gonna do both summation of forces and summation of moment. And since it's a combination of our past topics, these are the equations that we will use for resultant of non-concurrent force system. So as usual, Rx is summation of Fx, Ry is summation of Fy, and M is summation of forces times their perpendicular distances, or if you use Varanon's theorem, that's components multiplied by their distance. And then to get the resultant R, Pythagorean theorem, square root of Rx squared plus Ry squared. This resultant R dictates the motion of your object, specifically its translational motion, meaning its linear direction, so up, down, left, right, or at an angle of however degrees, and that degrees, angle of inclination, is taken from the equation tangent theta x is equal to Ry over Rx, and remember, this theta is always taken from the x-axis. Okay? So that's it. Combination of everything we discussed so far. So therefore, let's begin with our examples. Let's start with number 1. So for number 1, again, I'm gonna solve for this on my own. You can just listen. I'm not gonna take recitation yet, okay, but you can solve along if you want to. But again, I'm not taking recitation yet. So number 1, determine completely the resultant of the forces acting on the step pulley shown in the figure. So you have this step pulley here, we have this 750-pound force, 1250 and 250 pounds. So let's solve. When we say determine completely, that's taking the resultant R, its inclination, and its position. So we're looking for 3 things when we're determining completely the resultant of a non-concurrent force system. Okay? So number 1, so we're looking for R. We'll begin with the resultant R. But as you can see, our forces have different directions. So we're going to look for Rx and Ry first, and then we can solve for R. So let's start with Rx. Okay. So Rx, combination of all the X components of each force. So we have this force here, the 750-pound force. Let's take its X and Y components. So this is its X component. And this is its Y component. So how are we going to get this X component? We're going to look at the figure. So we're given an angle here, right? This is 60. And recall, alternating interior angles, meaning this way. These are alternating interior angles and they are equal. Now looking at the figure, these are also alternating interior angles. If this is 60, therefore, this is also 60. Take note, this is 60 degrees. Now remember, in our equation, you always want the angle to be from the x-axis, right? So my concern is getting this, right? Now, this line is actually the radius of your circle. And if you remember, okay, if this force is tangential to the circle, which it should be because this is a pulley, all forces from the pulley are tangential from the pulley itself. So this is a tangential force. This is the radius. From your previous math subjects, remember, the radius of a circle is always perpendicular to the tangential force or any tangent line. So that means this whole thing is perpendicular, this and this, so it creates a 90-degree angle. If this whole thing is 90, therefore to get this, that's just 90 minus 60, so this angle is 30 degrees. Okay? So let's actually draw a free body diagram first so that we have a better idea of our system of forces. Okay? So this is the center of the pulley. We have a radius here. We have our force, which is 750. Okay. We have another force here, a certain distance, and this is 1250. And then we know this is 60. Okay. And then therefore this is also 60. And then these two are tangential, so this is 30. Okay, and then we have another force here. We won't draw that yet. Okay. So now we can solve for summation of forces X or Rx. Okay. Let's start with this force. We're given an angle, so we're going to use the equations involving angle. So X component is F cosine theta. So F 750 cosine 30. To the right, sign convention still applies. It's to the right, therefore positive. Next, look at the other forces. This 1250 force is downward, that doesn't have an X component. And then we have another force here, which is to the right, so that's positive, and it's not at an angle, so that's just positive 250. And then if you solve for this, you should get 899.52. And then, as usual, ideally, you want to store that. After solving for Rx, next solve for Ry. Once again, starting with 750, it's upward, therefore positive 750, y component, therefore sine 30. Okay? Next, what else? This 1250 force is downward, so minus 1250. And then this doesn't have a vertical component, so ignoring that, solving for this, we should get negative 875. And so finally, our first answer R is just square root of Rx squared plus Ry squared. Plugging in what we solved for, we'll get 1254.89. And then unit counts. Okay, so this is the magnitude of the resultant. Next step is to get the inclination, which is your theta. And theta is just arctangent absolute value of Ry over Rx. Or you can just ignore the sign and input the values. Okay, Ry over Rx. Solving for that, we get positive 44.21 degrees. And then to get the direction, look at the sign of your components. Rx is positive, therefore that's to the right. Ry is negative, therefore that's downward. So write that here, downward to the right or down to the right, or you can just draw your arrow or write it out. Down to the right. Okay. And we're not done. The last step is to look for its position. Position meaning where to a reference point is this resultant located. Okay, so it's downwards to the right. So you're gonna guess where that resultant is. Now you're gonna choose a reference point. point first, similar to your resultant of parallel forces where we choose a reference point. And then to get the position, we're taking moment about that point. Okay. So since there's no support here, this is just a pulley. So usually our reference point is the center. Okay. So center, let's take moment about center. Let's call that MC. And recall the equation MC equals RD. For summation of MC equals RD. Okay, let's begin. MC, again, that's force times distance. Once again, let's begin with 750. Now, this is the center. It's your center C. We want to know the perpendicular distance of 750 C. If you don't want to do that, you can take components, Baranon's theorem. However, for this specific example, as you can see, radius is given, right? It's 1 1/4, or 1.25 feet. Since this radius is given, and that radius is perpendicular to 750, this is actually already the perpendicular distance to our reference point, which is C. So I'm not going to use Baranon's theorem anymore, okay? So I'm going to use its actual perpendicular distance. Next, rotate that about C. This is 750, rotate about C. Clockwise, therefore positive. 750 multiplied by perpendicular distance, 1 1/4 feet, or 1.25. Next, continue on with the other forces. We have 1250. And as you can see, this length is also given. It's a half feet or half foot. So 1/2 or 0.5 feet. Okay? This distance is perpendicular already to our force. So once again, I'm not going to use Baranon's theorem. And then rotate 150 about C. That's counterclockwise, therefore negative 1250 times distance 0.5. So negative 1250 distance 0.5. And then lastly, you have your 250-pound force. Okay. Now, this is the perpendicular distance to your center. And that is actually the radius of your pulley. And that radius is already given. It's here. It's 1 1/4. So once again, you already have your lever arm or moment arm. So I'm not going to use Baranon's theorem. And now rotate that. That's once again counterclockwise. So negative 250 times radius, which is 1 1/4 or 1.25. So negative 250 times 1.25. And then equate that to RD. This is your R, 1254.89. Okay? So you're gonna guess where your R is, because we want to guess its its direction. So let's say it's over here. It's above the center. So if you take that above the center, or about the center, that's gonna be clockwise. So positive R. Okay. Again, we're assuming R is placed above the center, or R acts above the center. So positive R. And then D is what we're looking for. It's distance from our reference point. So that's distance from the center. Okay. So down to the right. Again, I'm guessing it's above, and this is D. Okay. That's what we're looking for. For D. Then R is 1254.89. Now, actually, if you solve for this, okay, you'll see that D is equal to 0. Okay, if you compute for this, that all equates to 0. Therefore, your resultant is at the center of the pulley. It's at the center. Okay. And now take note of this. Okay. For a pulley, resultant of all the forces acting on the pulley is at the center, right? So meaning, whenever you have a pulley, okay, if you have these forces, you can redraw that into acting at the center as well, okay? Or you can take the resultant and then draw that as just a single force, okay? Because sometimes resolving your forces into a single resultant force is easier to analyze. So remember this, resultant of a pulley always acts at the center. So we can simplify our drawings whenever we encounter a pulley. Okay? So that is number 1. Any questions for number 1, please answer in the chat. Okay, great. Let's move on to number 2. Ready your calculators? I'll be taking recitation now. All right, number 2. Completely determine the resultant with respect to point O of the force system shown in the figure. So once again, completely determine, that's magnitude of resultant, inclination, and position, and it's specified with respect to point O. Okay, so don't have a choice. We have to take our reference point as point O. We have another matrix or grid system. Okay, so that means whenever we have a diagonal force, we need to get its slope if the angle is not given. Okay, as you can see, here angle is given, here slope is already given, angle is given. The only thing we need to solve for now is this. We need to get the slope of that, because most likely, as we've experienced in the past, if I were to extend that line of action and recall, our reference will be point O. This is the perpendicular distance, and that distance is tedious to solve. So we're going to use Varadon's theorem for the 141.4 Newton force. Okay? Great. So let's get its slope. Okay? The method is to look for how many sides or full boxes it takes to complete a right triangle. As you can see, that's just 1. Okay, yan. So the slope here is 1:1. Then compute the hypotenuse, square root of 1 squared plus square root of 1 squared, that's square root of 2. Okay. And now, to get the resultant, we're going to use a component method, solving for Rx first and Ry first. Let's try starting with Rx. Okay. Rx is summation of forces x. So I like to start with the leftmost force, so let's start here. Okay, so this is 240. Check for the sign. It's to the left, therefore that's negative 240. And look here. Okay, this angle 30 degrees is given from the vertical side or from the y-axis. Remember, the equation that we're using necessitates that the angle should be from the x-axis. So we can solve for that. Okay, that's easy. If this is 30, this is 90 degrees, so this is 60. Okay, so you can do that, and therefore we can use the equation cosine for x component and then 60. If you don't want to do that, okay, just remember the concept of our trigonometric functions. That's how we got our equation in the first place. Okay, if this is what we're given, angle from the y-axis, we're looking for the x component, which is this, right? Therefore, we can project that here. And then taking into consideration this right triangle, x component is actually opposite of the angle. If it's opposite, therefore, we're going to use sine. Okay, so therefore, this will be, instead of cosine 60, sine 30. Okay, you may do that as well if you don't want to solve for the angle from the x-axis. Okay, so instead of cosine, this becomes sine 30. Okay, but for uniformity's sake, I'm going to solve for the x component. Okay, so that's why we'll still use cosine. Okay, force 1 is done. Let's move on to this. It's to the right, therefore positive. 141.4 multiplied by the horizontal side, which is 1, over hypotenuse, square root of 2 to get its x component. Next, here, to the right, therefore positive 300. Once again, we have another angle from the y-axis. So let's solve for its angle from the x-axis. This is 60, therefore this is 30 degrees. So cosine 30. Once again, you can use sine 60 if you want to. Okay, And then lastly, we have this again to the right, so positive 260 horizontal, so times 12 over hypotenuse. Let's solve for the hypotenuse. Square root of 12 squared plus 5 squared, that's 13. 13. So over 13. There's no more 4s. Please solve. What's the answer for Rx? Correct. It's 479.79. Correct. Matthew and Lauren. Canelon, Tua. Okay. 2. Then store that in your calculator. Okay, for 79.79. The entire value. Positive, right? Don't forget, sign is important. Store. And then do the same thing for Ry. Ry. Once again, let's start with 240. It's upwards, therefore positive 240 sine 60. Upward, therefore positive 141.4 times vertical side 1 over square root of 2. Next, downward, therefore negative 300 sine 30. And finally, upward, so positive 260 times vertical side 5 over 13. Please compute. What's the answer? Correct. 257.83. Correct. Zyra and Kurt. Or this. And store that. 257.83 store. Now I can solve for R. R is just square root of Rx squared plus Ry squared. And we already know Ry and Rx, so please solve what's R. Correct. It's 544.68. Correct, Rafaela and Len. Pangalangan and Pelios. Wala. So 544.68. That's the unit Newton. That's our answer, first answer. We're gonna use this, so also store that value, just for easy retrieval and for accurate answers. We're not done. I need to know the inclination. So that's arctangent, absolute value of Ry over Rx. Please solve. What's theta? Correct. It's 28.25. Correct. Once again, correct. Zyra and Ella. Or please. .25, and then direction. Look at the sign of our answers. Both of them are positive. Therefore, that's up to the right. Up, up, or upwards to the right. Or again, you can just draw an arrow. We're not done. We still need to get its direction. We're already specified, or the problem specified, our reference point is O. So we're going to take moment about O. Okay? So summation of moment about O, and then we'll equate that to RD to get D. Okay? So if we do that, let me just make everything smaller because it doesn't fit. Okay. Okay. Now if we do that, okay, MO equals RD. I'm gonna simplify this, right? So this is our grid. This is your point O. Okay. I'm gonna extend this here. We already know our resultant is upwards to the right. So once again, we're gonna assume where that position is. Usually we're assuming it's above point. So upwards to the right, that is our resultant. Okay? So this direction can either mean the perpendicular distance to point O, okay? Or we can look for the x and y intercepts because those are also distances from point O. Okay? So this is IY, IX. Okay? We've already solved for problems like this, right? Solving for IY and IX. The step here is to solve for moment about point O, and then use this equation to solve for IY and IX. So let's do that. Let's begin with solving for moment. So moment about O. Let's go back to our figure. Okay? And let's start again from the left-hand side. So starting here, 240, it passes through point O, so I'm going to ignore that. Next, 141.4, I don't know its perpendicular distance to O, so we're going to use component method. Component method. Okay. I'm going to place my component here so that the Y component passes through O and it cancels out. So we're left with the X component. Rotate that about O, that's positive. So positive X component of 141.4. So 141.4 multiplied by 1 over square root of 2 to get its horizontal component and multiply that by its perpendicular distance. That's 1, 2, 3 boxes. Each box is 1 meter, so that's 3 meters. Okay? Do the same thing for the others. We have this, the 300 Newton force. Once again, get its components. Okay? Neither of the components pass through, also will solve for both. Let's start with X component. Rotate that about O, that's positive. Therefore, that's clockwise. Therefore, positive 300. X component is cosine 30. So plus 300 cosine 30. Don't forget the distance. Extend this line of action. This is the distance. That's 1, 2, 3, 4 units. So 4 meters. Okay. Next, the Y component. So this one, rotate about O. Once again, clockwise. So positive Y component. So that's sine plus 300 sine 60. And don't forget, perpendicular distance. Extend that line of action. 1, 2, 3, 4 units to point. That's times 4. And last, we have this. Okay. So once again, there's no component or there's no way for one of the components to pass through O. Okay. This doesn't give, or this doesn't land on an intersection of the square. So I can't do that. So I'm going to do this instead. Varnon's theorem. Let's start with X, rotate about O, clockwise, so positive 260. Get the horizontal component, so that's 12 over 13. Multiply by distance, and that's 1 unit, so times 1. And then lastly, Y component, this one rotate, that's counterclockwise. So negative, dito ko na lang lalagay, ha? Negative 260 times y component, so 5 over 13. Perpendicular distance is this, so that's 1, 2, 3, 4 units. Please compute what is this entire thing. Correct, Kurt? And Len. Peliosis de la Cruz. It's 1779.19. Positive. Start. Okay, let me just double check kung tama sinulat ko. 141. Yep. 300 sine 30 times 4. Yep. 300 sine 60 times 4. Yep. 260, 12, 13, 1. Negative. 265, 13, 4. Yep. Oh, mag-double check yung iba sa inyo na hindi nakakuha ng 1,779. Great. Now I have my M. I have R. Recall the equation that we're using. Okay. I'm gonna place components of my resultant here. Okay. Let's start here. Right. So moment about O equals, this is Rx, Ry, Rx, Ry. So as you can see here, Ry passes through point O, so ignoring that, okay. Rx passes through point O, so we're gonna ignore that. This is X. Okay. So Ry rotate about O clockwise, so positive Ry multiplied by perpendicular distance Ix. And O is this. Right? Ry is this. So we know both values, so please solve what's Ix. Ix. Correct, Ella. Correct, Naomi. Correct, Jomar. So, pangalangan. 2 points ka na. So, next, Minyoso. And then also, you. 6.9 or 6.90. You divided by Rx. That's why some of you got the correct answer. And then unit, our unit of measurement is meters. So 6.90 meters. And then to get y, MO equals, taking this side, Ry passes through point O. So ignoring that, Rx rotate about O clockwise, so positive Rx. Perpendicular distance Iy. We know MO and Rx, so please solve what's Iy. Ah, 3.71. Correct. Correct. Rafael and Simon. Chero. All right. 3.71 unit is meters. There. Both answers are positive, so it is indeed above 0.0. Okay. Now, if you want to take this perpendicular distance, you may do so by just MO equals RD. R is 544, MO is 1779. You'll get this distance D, okay? If that is what we're looking for. So that's number 2. Any questions for number 2? Please answer in the chat. Right, great. Let's move on to number 3. Okay. Number 3, we have another truss. So the Howe roof truss shown in the figure carries the given loads. The wind loads are perpendicular to the inclined members. Determine the magnitude of the resultant, its inclination with the horizontal, and where it intersects AB. So basically, we're solving completely the resultant. So magnitude, inclination, that means your theta, and where it intersects AB. So we're not given a reference point, so we're going to choose that. So where it intersects AB, this is your chord AB. So you can either take your reference point at A or B to know where it intersects. As usual, I like taking it about the left support, so at A. So let's begin by solving for resultant. Okay. So that means beginning with Rx. So let's jump right in, Rx. Let's start with the leftmost force. Okay. So we have this, right? We don't have an angle. Therefore, we're given dimensions though, distances. So most likely we're gonna need slope. Now it's specified there that these are wind loads. And when we say wind loads, that means all of these are perpendicular to your truss. Okay? Now to get this angle, okay, I need to know, or sorry, to get this slope, the slope of our forces, they're all parallel, so they have the same slope. I just need to know the slope of the line perpendicular to that. So that means taking the slope of this chord, which is easy because as you can see, okay, taking this right triangle, you can see that the height is 3 and the base is 6. So we can solve that. We can write 3, 6. Or if you want the lowest term, divide everything by 3. So 1 and 2. 1, 2, and then this is square root of 5. Now, once you know the inclination or the slope of the line perpendicular to your force, you can transfer that to the force. Okay, and then to transfer, you can analyze if you still don't know the technique here. So to analyze, we're going to use, or you can use your theorem on perpendicular angles. So remember, let's say if we have this angle and we have an angle perpendicular to that, so meaning this angle, okay, let's choose a different color. We have another angle. So these two are perpendicular. Whatever is this angle, it's equal to this angle, okay? Meaning whatever is this measurement is equal to this measurement. So if you analyze that here in our drawing, okay, perpendicular angles, right? This line, let's draw a straight line here. It's gonna be perpendicular to the bottom or to the base of this right triangle. And this line is already perpendicular to the hypotenuse. Okay? Let's take these two as the angles, right? Or these to show it's bigger. Opposite side of this angle is 3. Therefore, the opposite side of the slope that we're creating would be 3 as well. Okay? And then therefore, the other side would be 6. So let's do that. This is 3. This is 6. And then this is square root of 5. We're going to simplify. Instead of 3, 6, this becomes 1 and 2. Okay? So that's how you transfer slope. Or, if you don't want to go through that, just remember for perpendicular lines, the slope is just the inverse. Okay? For example, here, horizontal is 2. Therefore, on the other line, it's going to be the vertical. So this will be 2. Okay? Yan. Right? In the same way, vertical here is 1. It's the opposite on the other side. Here, the horizontal is 1. Okay? So you can just remember that. It's the reverse of the other angle. Okay? So that's now the slope of our forces. All of these have the same slope, so I don't have to solve for that. And let's continue with our equation. Okay? So let's start here. 1120. It's to the right, therefore positive 1120. X component, so that's horizontal divided by hypotenuse. So 1 over square root of 5. Okay, let's move on. 2240 to the right, so positive 2240 and same slope. So that's still 1 over square root of 5. Same thing here, it's to the right, so positive 1120 times 1 over square root of 5. These three don't have horizontal components, so ignoring that, and this is directly horizontal, so plus 2000. That's all the forces. Please solve what's Rx. Correct. 4003.52. So correct, Simon and Geyser. Chero de la Cruz. Store that. 4003.50. Okay. Again, try to store. Next, Ry. So 1120, starting here, downward, so that's negative. 1120, vertical component, so vertical side, that's 2 over hypotenuse square root of 5. Now, if you've noticed, these two are parallel, okay, and they have the same magnitude. So since they're the same, I'll just multiply this by 2, okay? Since as you can see, they give the same equation. So I don't have to solve for that anymore. Next, this is also downward, so negative 2240 times 2 over square root of 5. Once again, this is already here. Next, downward, so negative 3000, negative 2000, negative 1000. This does not have vertical component. So that's it. Please solve what's Ry. Correct. Negative 10,007.03. Correct. Francisco and Colin. Important yung sign. Kulang ng negative. Colin. Si ano muna? Francisco, Legado. Okay, correct. Eman. So, Centones. It's negative. 10,007.03 and store. Okay. Ano ba nilagay ko? Bakit iba sagot niyo? This is square root of 5. Yan. Kaya siguro mali yung iba. Alright. Ry, Rx. I can solve for R. Please solve what's R. Correct, Michelle. And Kenneth. De la Cruz. Oh. Okay. 10,778.17 unit Newton. Next part, getting the inclination. So that's just theta. Arctangent, absolute value Ry over Rx. Please solve. What's the answer? Correct. 68.20 positive. Andrew, correct. And Kenneth. So, De La Cruz, Thailand. .20 degrees. Remember, theta is always positive because we're taking the direction from our Rx and Rb. Both of them are positive, therefore that's okay. Ry is negative, Rx is positive, therefore that is downward to the right. Or just down to the right. Next. Okay. Next part, where it intersects AB. Okay. So this is AB. Okay. We want to know where does it intersect. We're going to take a reference point. It's either A or B. Again, I'm used to taking it at A. So now you're going to guess the position of your resultant. We know it's downwards to the right. So you'll guess. I'm going to guess here. Okay. Or maybe here. Okay. So this is R. Okay. Since I'm taking my reference at A, this will be our distance. This is our answer. D. Sorry, where it intersects AB rather. Okay? Where it intersects. So this is our distance, D. Okay? Not this, where it intersects, so this point. Let's extend that so we can see it better. Okay? Okay. So that's easy to know D. We're just gonna use moment about A. So MA, or summation of MA equals RD. Okay, in this case, since we're concerned with this distance D, okay, we need to solve this into components. So let's resolve that. Okay. Oh, wait, let me fix the drawing. Lipat ko lang to. I'm gonna place that here. 2, 1, square root of 5. It's the same thing. So that you can see better. And this is R. Okay. This is what we need. This is D. Okay. And then, since I need to know D, it's a horizontal distance. Okay. If we just solve for RD, the D that we'll get is this, right? Perpendicular distance from our reference point. That is not what I want. I want where it intersects at A toward AB. That is this distance D from point A. So that's why I need to resolve it into components and place it at this point. So that Rx, Ry, Ry passes through A, we're left with Rx, and its perpendicular distance is B from A. Okay? Once again, Ry passes through A, so ignoring that, we're left with Rx, rotate about A, that's clockwise, therefore positive. Okay, so MA equals positive, okay, it's RD, and that is also equal to Ry times Ry, baliktad. Or X or Y. For Y times distance. And now we have to create an equation for moment about A. Let's begin. Let's start with from the leftmost force. We have 1120. It passes directly through A. So I'm going to ignore that. Next, we have 2240. So I need to resolve this into X and Y components. Or if you want, okay, solve for this perpendicular distance. Okay, let's do that. So if this is 3, oops, sorry. So yung distance na gusto natin. And we know that's the hypotenuse of this right triangle with base 3, and we already know the slope of this. So to get this length, you can use ratio and proportion, right? So I'm gonna do this on the side. So we're given base. So I'm gonna do hypotenuse over base is equal to hypotenuse over base. Hypotenuse over base 3 equals, this is what we want. Let's call that L1 over base 5 over base 2 equals L1 over base 3. And then from this, what's L1? Right, it's 3.35. To store that in your calculator, so correct Nicolas and Geyser, so De La Cruz and Buena. Okay, so 3.35. We're gonna do the same thing here. However, okay, take note, you can just multiply this by 2 to get the perpendicular distance of 1120 from A. Or if you want, you can also again use ratio and proportion, considering this large right triangle. Okay, and then this is what we need. This is our L2. Okay, this is L2, the entire span. Okay. Okay. So ratio and proportion. Once again, square root of 5 over 2 for the slope equals total base is 6. And then this is L2. So L2 over 6. L2 equals 3.35 times 2. And that's just 3 square root of 5. Okay. Alright. So now we can continue on with our equation. So just 2240. Okay. It's clockwise, so positive, and then this is the perpendicular distance equal to L1, and that's 3.35. So times L1. Next, 1120, rotate about A, clockwise, so positive 1120. multiplied by perpendicular distance, L2, which is 3 square root of 5. So times L2 or times 3 square root of 5. Next, we have 3,000. Rotate about A. Positive, therefore clockwise, therefore positive 3,000. Perpendicular distance was 3, as you can see. Next, 2,000 clockwise, so positive 2,000. Perpendicular distance 6. Next, 1,000 clockwise, positive 1,000. Perpendicular distance 9. And what else? 2,000. Clockwise, so positive 2,000. Now, how about this? We need the perpendicular distance, right? And this is the perpendicular distance. So how do we solve for that? We're going to do the same thing we did here. By the way, this is ratio and proportion. So let me specify by ratio and proportion. Okay, so we're going to do the same thing. Now, this is what we need, perpendicular distance. And that's equal to the height of this right triangle. So we're going to do the height of our slope, height over hypotenuse. So height over base, since base is what we know from this right triangle. So 1 over 2 equals this. This is what we want. Let's call that y. Okay. It equals y over base 3. So y equals 1 point. Okay, therefore perpendicular distance of 2,000 is 1.5, or you can write y and y is 1.5. There's no other force. Now equals Rx. We already know Rx. It's this. Rotate that. That's clockwise. So positive Rx. And we want to know positive Ry. Sorry, Ry. Positive. So positive 10,000. Okay. Times B. Okay. So please solve what's B. Correct, 4.80. Correct, Eman and Michelle. So, Santones, yeah. Okay, 4.80. Positive, therefore our assumption is correct that it's to the right of A. So 4.80 unit is meters, right? Meters. To the right or from A. And that is where it intersects member A. Okay? Now, if you don't want to go through this ratio and proportion, we can do what we've been doing, which is resolve this into X and Y components. Okay? So if you want to practice, you can do that. Solve for X and Y components. That's going to take longer, but it's great for practice. You should get the same answer. Okay? So that's number 3. Any questions for number 3? Please answer in the chat. Okay, great. Gets naman yung ratio and proportion, right? It's just equating the sides of a right triangle, or equating sides of a right triangle. Okay? Since no questions, let's move on to number 4. medyo, we have an application to engineering for number 4. Determine the resultant of the 3 forces acting on the dam shown in the figure and locate its intersection with the base AB. For good design, this intersection should occur within the middle third of the base, so does it. So let's focus on the first part. Determine the resultant of the 3 forces acting on the dam and its intersection with the base AB. Okay, so we're looking for magnitude, inclination, and point of intersection, and this is your point AB. And these are your 3 forces. So even though the drawing is a bit different, the solution is the same. We'll start with Rx. So Rx, let's start with the leftmost force, P to the right, therefore positive 10,000. Next, 24,000 downward, no X component, ignoring that. Then we have this force F to the left, so negative. Now I need to get its X component. Now as you can see, we have this angle here. So I need to transfer that to this force. Now, remember what I said earlier? When you have, let's choose green. When you have two intersecting lines, okay, its slope is the reverse. Same thing here. Its angle will be a complementary angle. Meaning complementary to 60, that's 30, right? So this is 30. Or, if you don't want to go through that, okay, alternating interior angles, if this is 60, therefore this is also 60. This is perpendicular to this line, so therefore this entire thing is 90. So 90 minus 60, that's 30. Okay. As you can see, there are several concepts that you can use to figure out angles in your drawing. Depends on what you're most comfy with. Okay, so that's 30. So that's negative 6,000 cosine 30, since 30 is an angle from the x-axis. There's no more force, so please solve what's Rx. Correct, it's 4,000. Correct, Paulo and Gian Bustos Aldobe. Four 803.85 store. Next, RY. No Y component, downward, negative 24,000. Downward, negative 6,000. Sine 30. Please solve. Correct, negative 27,000. Very good. Again, sign matters. So correct Matthew and Lauren. Anilon to negative 27,000. No need to store because it's a whole number. And then next step are, please solve what's R squared. Correct, Lloyd and Francisco. So Legado and Sosa. Legs. 27,000. 27,424.02 unit pounds. Okay. Next, you want to know its inclination. arctangent. Please solve. What's theta? Correct. It's 79.91. Who got it? Correct, Naomi and Colin. Very nice. Always positive direction. Ry is negative, Rx is positive, so that's down to the right. Okay? And then, next question, locate its intersection with base AB. So this is your base AB. Now, I've mentioned earlier that usually I want to take our moment from the left support. So I would have taken moment about point A, but I won't because look at what's more convenient. Okay? If I take moment about A, I don't know the perpendicular distance of 6,000 from point A. It's this distance, right? And I don't want to solve for that. However, if I take it about point B, the distance of force F from B is already given as 4 feet. So therefore, I'm just going to take moment about B. Okay, so please analyze what's the more convenient approach. That's moment about B. Next question is, I want to know its intersection. So like what we did earlier, you're going to guess where your R is. It's down to the right. So let's guess. I'm going to guess this is where my R is. That's R. I want to know its point of intersection. So like what we did earlier, I'm going to resolve this into X and Y components. Okay? Ry, Rx. Okay? And then this is what we want to know. Okay, wait lang. Let me move everything downward. Yeah. That's what we want to know. This will be our point D, distance from point B. Okay? So I'm going to take component here. Rx will pass through B, so I'm going to ignore that. And next, we have Ry. Rotate Ry about B. That's counterclockwise. Okay? So equals negative equals Rd. But it's also equal to negative, since it's counterclockwise, Ry times D. Okay, now let's create our equations. Let's start with 110,000. Rotate about B, that's clockwise, therefore positive 10,000. Perpendicular distance is given, and that's equal to 6. So positive 10,000 times 6. Next, 24,000. Rotate about B, that's clockwise, counterclockwise, so negative 24,000. Now, what is its distance? This distance is 7 feet. And that's from the left side. I want to know distance from the right side, from B. This total length is 18. So distance, this perpendicular distance is just 18 minus 7. Okay, so 24,000 times 18 minus 7, or just 11. And lastly, yeah, rotate counterclockwise, negative 6,000. Distance is 4. Equals negative Ry. Again, Ry is this, positive 27,000 times D. Please solve what's D. Divide by Ry. Correct, it's 8.44. Correct, Lloyd, Sosa, and Colin. Colin. Okay. 8.44. Unit feet. Positive, therefore correct assumption. It is between A and B, so it's to the left of B. And then let's answer the next part. For good design, this intersection should occur within the middle third of the base. Question is, does it? Now our base is 18. So let's divide that into 3. Okay? Okay? This is AB dividing into 3. And if this whole thing is 18, divide into 3, the 6, 6, and 6. And this is where it should land. Okay, for good design. Now, as you can see, D is actually 8.44 to the left of B. Okay, it's less than 12 because this entire thing is 12, but it's greater than 6. Therefore, just from the drawing, you'll say that yes, it is within. The question is it or does it intersect the middle third? It intersects the middle third. Or you can just answer yes. And that is the last number for resultant. Any questions so far for everything? Please answer in the chat. Okay, no questions. That ends our topic for resultant. On Saturday, as I've mentioned in the previous meeting, we'll have a quiz. Okay, your first quiz. So it's open camera, join the Zoom meeting. Okay, no camera or no video, no score. So same with your seat work. You're just gonna answer the assessment, or same with your diagnostic exam, you're gonna answer the assessment. And then you're gonna upload the solution later on. Deadline of the actual quiz, answering the assessment, is holiday. Holidays is Saturday. Uh, never mind then. Your quiz will be on Tuesday next week. Okay, so take this time to study. Exam on Tuesday next week. So same thing. Open Zoom meeting, no video, no score. Deadline of assessment is 1:30 p.m. Deadline of solution is 11:59 p.m. End of day. Okay? Coverage is everything I've discussed so far. Everything I've mentioned so far. Right? And then on Thursday, depends. Lecture or group activity. We'll see. Most likely there's lecture. And then there will be group activity. Okay? I'm gonna group you on Thursday as well. So just keep that in mind. Once again, quiz on Tuesday. Remember open camera. Please study. Coverage everything I've discussed. Alright? Any questions? Any clarifications? Yeah? Sure? Okay. Reminder, deadline of your SeatWorks hard deadline is this Saturday. You don't have to message me if you haven't answered it yet. Just answer it. I don't need an excuse letter for SeatWorks. Okay. Then I need excuse letter if you're absent on quiz days. Saturday is a holiday apparently. Okay. No classes on Saturday because it's a holiday. If Mapua says no classes, then no classes. Okay. So therefore, our next meeting is Tuesday, and that is when our exam will be held. Okay. So no more clarifications. Okay na? Okay. Since you don't have any more questions, enjoy your holiday. You may go. Bye, class.
Thank you po.
Thank you po.
Bye, ma'am.
Thank you po, ma'am.
Thank you po, ma'am.
Thank you, ma'am.